When you think of Switzerland, what comes to mind? Is it the majestic Alps, the pristine ski slopes, or perhaps indulging in a warm, gooey fondue after a day on the pistes? But Switzerland is not just about postcard-perfect landscapes and delicious cheese. It's a nation synonymous with innovation. From the indispensable Swiss Army knife to the ingenious Velcro, the Swiss knack for inventiveness knows no bounds. And let's not forget, it's here amidst these snow-capped peaks that the World Wide Web was spun and the Higgs boson leaped from theory to reality thanks to the brilliant minds at CERN. But today we're interested in a different kind of innovation, Switzerland's energy transition. It's a journey as Swiss as it gets, intertwining the country's commitment to precision, efficiency, and environmental stewardship, all the while maintaining that high quality of life the Swiss are known for. And while fondue might not directly fuel Switzerland's green future, the spirit of sustainability certainly melts into every aspect of this transition. Join me, Rosie, as we explore how Switzerland is reshaping its electricity mix, transforming its buildings, transport, industry, and agriculture, and leading with cutting-edge Swiss technologies to pave the way. So buckle up, or should I say, fasten your ski bindings as we embark on this exciting journey. Welcome to Engineering with Rosie, reporting right from the heart of Switzerland. Switzerland's motivation to tackle climate change is vividly etched in the rapidly changing landscapes of its famed Alpine region. The retreat of alpine glaciers is a stark reminder of the urgency for action. Since the mid-19th century, these icy giants have lost about 60% of their volume, unavoidable evidence of the warming climate. But it's not just the glaciers that signal change. The very essence of the Swiss winters is transforming. Snowfall is becoming rarer. At elevations of 2,000 meters, snowfall has decreased by 20% since 1970. And at lower altitudes of around 800 meters, it now snows only half as often as it did back then. This decline in snow not only shortens the ski season, a cornerstone of Swiss culture and economy, and the reason why I'm here, but it also signals profound ecological shifts. For Switzerland, action on climate change is not just a global responsibility, but a national imperative to preserve its natural heritage and the very lifestyle that defines it. Switzerland's journey towards eliminating its carbon footprint is already off to a promising start, thanks in part to its already low per capita emissions compared to the European standard, and even below the global average, which is pretty good for such a wealthy country. This is largely because of its rich natural hydro resources. Hydroelectric power makes up over half of its electricity mix. Most of the rest is nuclear energy at 30 to 40%. However, Switzerland is not without its challenges. The country's cold winters mean a lot of energy to heat buildings, and the mountainous terrain makes infrastructure projects more complex, impacting sectors from transport to energy distribution. Emissions in Switzerland are generated by transport, accounting for 32%, followed closely by the building and industrial sectors, each contributing 24%. Agriculture is responsible for 16% of emissions. With a commitment to achieving net zero by 2050 and an intermediate target of reducing emissions by 50% by 2030, Switzerland has some big changes to make. Let's take a look at the most interesting parts of their plan. We'll start with electricity. Switzerland's electricity grid is already pretty clean, made up of over 97% renewable plus nuclear. But despite this, it's set to undergo a major transformation. The country is moving to phase out nuclear power, a decision largely influenced by the Fukushima incident in 2011 and preceding challenges in gaining public support for new nuclear projects. Switzerland's approach is more measured compared to some, opting to let existing nuclear facilities operate until the end of their natural lifespan. The country has 4 nuclear reactors totaling about 3 gigawatts that, up until recently, generated up to 40% of its electricity. In a decisive move, a few months after the Fukushima accident, Parliament resolved not to replace any reactors, and that decision was reinforced by a 2017 referendum. To fill the impending void left by nuclear energy, Switzerland is turning to renewables, particularly solar power, which has recently seen rapid adoption. In 2023, the country installed 1.5 gigawatts of solar, bringing total installations to 6.2 gigawatts and contributing that year about 5% to the national electricity output. With the expected installation of 2 gigawatts of new solar annually through 2027, solar power is on track to quickly supplant the nearly 3 gigawatts of nuclear. Much of the policy support for solar is aimed at integrating distributed solar energy into the grid, with the intention to open up opportunities to create district system solutions and support electric mobility packages. This focus on solar might sound like a strange thing for a country like Switzerland to be pursuing. As an Australian, I'm no stranger to rooftop solar, of course. We have it on 1 in 3 houses back home, but we don't have snow covering most of the country for months of the year, and we don't have hundreds of historic villages whose beauty we need to preserve. What is Switzerland thinking? Turns out they're thinking very differently to traditional rooftop solar. Some examples are building integrated photovoltaics, which blend into roofs nearly invisible. I didn't even realize this roof was solar panels until it was pointed out out to be by my ski buddy, who happened to be the owner of the company that made them. His company also makes panels you can use on a lovely balcony or facade, whose vertical surface will never be covered by snow and can grab the winter's low-angle sun. These building integrated photovoltaics are a gorgeous example of Swiss innovation. Instead of orienting panels to capture the most possible energy over the year, which would mean maximizing midday summer capture, they can be oriented to maximize capture throughout winter, and especially in March and April, which is when the hydro reservoirs are at their lowest. Orienting solar panels to be most efficient at that time will have a lot more impact than optimizing for summer production when there's already plenty of production from solar and hydro. Clever orientation of solar panels can't completely overcome the variable nature of solar though. It is a fact that the sun sets and it doesn't shine as bright in the winter. To deal with that, there is hydro. Hydroelectric power has long been the backbone of Switzerland's electricity supply. 693 hydropower plants collectively generate around 37,000 gigawatt hours annually, more than half of consumption. The hydro production is almost evenly split between run-of-river and storage power plants, with a smaller contribution from pump storage facilities, about 4% at the moment. Looking to the future, hydro's potential as energy storage needs to be maximised. That means dam upgrades, mostly raising existing dam walls to increase the amount of energy storage, and especially adding pumped hydro capacity so that they can turn excess solar power into stored energy to use when they need it. On a daily basis, that means in the evenings when the sun is set. And it also needs to be there for cloudy days and cloudy weeks. And seasonally, they need enough dam storage left to get through the end of winter. One of the most ambitious projects underscoring this strategy is the Non-de-Drance facility, which was completed in 2022 after 14 years of construction. It is a massive pump storage plant nestled between the Emossen and Vieux-Emossen reservoirs near the French border. It's 900 megawatts and 20,000 megawatt hours, which means 22 hours of storage at full output, which makes it one of the largest of its kind globally. Switzerland's planned increase in hydropower storage capacity is not just a domestic affair. It holds significant implications for the broader European energy landscape. During summer months, Swiss hydro often produces more electricity than the country consumes, leading to exports when it's not really needed by the rest of Europe, which means it's sold at low prices and it doesn't contribute to Europe's energy security as well as it could if the timing could be better controlled. The rise of wind, and especially solar, exacerbates this surplus, creating a more pronounced disparity between summer production and summer consumption. By augmenting the storage capacity of its alpine lakes, Switzerland could more effectively vary hydropower production in response to the availability of wind and solar energy. This enhanced flexibility will not only benefit Switzerland, but also positions the country as a key provider of dispatchable power to Europe, facilitating the whole continent's transition to more variable renewable energy sources. In an era marked by the accelerating retreat of glaciers due to global warming, Switzerland is also exploring the construction of new dams in areas formerly occupied by these icy giants. Glaciers have traditionally served as a natural reservoir for Europe, storing water during the colder months and releasing it gradually throughout the year. However, with the majority of these glaciers sadly expected to vanish within the coming decades, the proposed dams aim to replicate this critical function in terms of water storage, and with the additional benefit of energy storage and generation as well. Moving from the electric grid to buildings, we encounter one of the primary contributors to Switzerland's carbon footprint. Heating is a fundamental necessity given the country's alpine climate, and it has traditionally relied on gas and heating oil. Buildings are responsible for about a quarter of the nation's emissions today. Switzerland's goal is to eliminate emissions from buildings by 2050, and the sector has already seen really significant progress with a more than 20% reduction in emissions, driven in part by the introduction of a CO2 levy on fossil-based heating fuels. The strategy for decarbonising the building sector hinges on two main pillars: the transition to low emissions heat sources and improving energy efficiency. Fossil fuel heating is being replaced with heat pumps and renewable energy sources, and there will be a shift away from inefficient, decentralised heating solutions towards more local and district heating systems. Equally important is the drive towards improving the energy efficiency of building. Switzerland is setting its sights high, aiming to minimise the energy consumption of its building stock to the lowest technically feasible levels. New constructions and replacement buildings are expected to adhere to stringent energy efficiency standards, offering homeowners incentives to enhance insulation and reduce energy wastage. Because emissions from buildings have already declined a decent chunk, transport has now emerged as Switzerland's largest source of greenhouse gases. The nation's strategy to tackle this challenge aligns with global trends, centering on the electrification of ground transport. Digitalization complements this shift by promoting remote work and digital collaboration, reducing the need for travel and thereby cutting energy consumption. A significant shift from road to rail also forms a critical part of the strategy, along with minimizing unnecessary travel and enhancing sustainability sustainable transport options like cycling. Now we get on to the hard parts of the transition. Everything we've mentioned so far should be able to be completely decarbonised without too much trouble. But now we need to address the sectors whose decarbonisation is not as straightforward. Industry is a vital part of the Swiss economy, though it doesn't have any heavy industry. Process heat is the primary source of industrial emissions in Switzerland, and it can be substantially decarbonised. That's a topic I've covered in a previous episode. But after that and all the other easy stuff is done, Switzerland still expects to only halve emissions from industry. The stubborn remainders are primarily from sectors like cement production, waste incineration, and the chemicals and pharmaceuticals industries. The path forward for these sectors is complex and require new solutions, which we'll explore shortly. But first, let's deal with agriculture, which has got to be one of the most iconic aspects of Switzerland and makes up 14% of Switzerland's emissions. If you think of Switzerland in the summer, you probably think of cows, and that is indeed where the bulk of their agricultural emissions come from, with methane from digestion making up about 45% of agricultural emissions. Soil management and manure storage also contribute significantly through nitrous oxide and methane emissions. Technological interventions such as optimizing fodder and more precise fertilizer application offer some mitigation potential. However, most of the reduction in emissions from agriculture is expected to come from lifestyle changes. That means eating less dairy and less beef and less food waste from households. That was a bit unexpected to me, coming from a country that intentionally invented and promoted fondue as a means to increase dairy consumption and support cattle farmers. With all their planned agriculture measures in place, that should lead to somewhere between 1 to 2/3 reduction in emissions from agriculture. So if you've been keeping track, all of the measures I've run through don't quite get Switzerland to net zero yet. There are still emissions left from places that are technically hard to decarbonise, like waste incineration, cement production, chemicals, and agriculture. So what's the plan for that? The plan for waste incineration starts with improving sorting to improve recycling rates. The Swiss are already keen recyclers, so that part makes sense. And then for whatever incineration remains, they say they're going to add carbon capture. Similarly, for the cement industry, carbon capture and storage, CCS, is considered essential to get rid of emissions. CCS involves separating CO2 from point sources like flue gases or cement kilns and then transporting it to be stored permanently underground. It's a controversial technology because there are a lot of examples of failed CCS projects over the past few decades and very few examples of successful ones. And it's made even more challenging for Switzerland because they don't have good domestic storage potential. So the CO2 would have to be transported over long distances. It's also expensive, transporting CO2 is risky, and the public generally don't like it. So not quite sure they're onto a winner there. For the chemical and pharmaceutical industries and agriculture, the challenge to get rid of the final bit of emissions there is even harder. CCS isn't feasible due to the lack of concentrated CO2 point sources. These sectors are likely to continue emitting and will need negative emissions technologies such as direct air capture, DAC, to balance out these unavoidable emissions. And it just so happens that one of the leading DAC companies, Climeworks, that I covered in my video on that topic, is another example of Swiss innovation. Climeworks launched the world's first commercial direct air capture plant on a Swiss waste incineration facility's roof in 2017. The plant used waste heat to power the machines, and the captured CO2 was used by a nearby greenhouse and to produce sparkling water for Coca-Cola. So that particular plant wasn't a negative emissions technology, as all the CO2 ended up back in the atmosphere. And anyway, it ceased operating in 2022. Now Climeworks has shifted focus to permanent underground CO2 storage at its Orca plant in Iceland, and that is very likely to be how Switzerland approaches its negative emissions too, with projects abroad where storage is easier. And speaking of abroad, I'm back home in Australia now, and we were nearly finished with this video when some breaking news came up that I needed to include. It's very easy to make emissions reductions targets and just say that you'll use negative emissions abroad to mop up whatever you can't get rid of locally. However, a recent legal finding has made it clear that nice words and vague plans aren't enough. Actual emissions reductions are required. And Switzerland is not on track. The European Court of Human Rights recently ruled that Switzerland has failed to meet its obligations to protect its citizens from the effects of climate change. This was in a case brought by a group of older Swiss women who argued that their rights were being violated due to the country's insufficient action on climate change. These women highlighted the particular vulnerability of older people to the effects of rising temperatures, and the court agreed with them. Switzerland has promised to, in good faith, implement and execute the judgment, which means coming up with ways to significantly enhance its domestic emissions reduction efforts and probably also adjust its reliance on international carbon credits. The court's decision against Switzerland marks the first time an international human rights court has ruled on climate change, which might seem to suggest that Switzerland is uniquely lagging in climate change. Climate Action Tracker assesses countries' reduction targets and whether they're on track, and they find that Switzerland's overall rating is insufficient. But so is the rest of Europe, with the exception of Norway, who are almost sufficient, meaning Norway is on track for reductions in line with 2 degrees warming if everyone else did as much as Norway, but not 1.5 degrees. And outside of Europe, most of the rest of the world is either highly or critically insufficient. So this decision doesn't say as much about Switzerland individually as it does about all of Europe, and really the entire world. And that's what's such a big deal about the finding, because this precedent seems very likely to influence future climate litigation across Europe and likely inspire similar cases elsewhere. Let's wrap up this exploration into Switzerland's energy transition by returning to where we began, a nation known for its landscapes and innovations. The journey ahead for Switzerland, like any, holds challenges as well as opportunities. I would love to return to Switzerland to ski again. Hopefully that will remain possible for decades into the future. I'm certainly hoping for energy transition success. To the Engineering with Rosie Patreon team, thank you for your support. For those intrigued by the complexity of energy transitions and wishing to support deeper analysis on this channel, consider joining the conversations on Patreon and our exclusive Discord channel. Thanks for watching, and I'll see you in the next video.